So our objective today is to learn about the theory of continental drift. Okay? Your essential questions for your notes are, how does the evidence that Wegener recorded support the theory of continental drift? So you're going to take notes over that. We're going to do notes a little bit different again. Remember I told you, you want to find different ways to take notes because you're not going to have a professor that always does PowerPoints. You're going to have some professors that lecture and just talk. You're going to have some professors that write the notes. You're going to have some professors that just kind of sit there and just start talking and you just get to write. Okay? So, we're going to do our notes a little bit differently. Basically, you're doing your notes off of a story. I'm going to read the story. Okay? So you're doing the notes just by listening, and we're going to stop periodically to talk about the different sections. Okay? But your essential question is, how does the evidence that Wegener recorded support the theory of continental drift? So, obviously, you were taking notes over a guy named Alfred Wegener, okay? And he's the one that came up with the theory of continental drift. So you're basically writing notes on what is the evidence that he acquired in order to prove that continental drift is, or to prove his theory of continental drift, or his belief, okay? So, as we go through, you're taking notes to answer that essential question. So, this is the story of Alfred Wegener. Alfred Wegener was born in Germany on November 1st, 1880. During his childhood years, Alfred became interested in the island of Greenland, where exciting new studies of geophysics were being made. He became determined to visit Greenland someday. He even made it a point to build and test his physical endurance so that one day he could endure the harsh climate of the desolate island. So, most people don't know that Greenland is actually a very harsh environment. People think Greenland, oh, it's green. It's not green. It's full of ice. Okay? It is very, very desolate. Iceland, who you would think was full of ice, is actually green. Okay? So it's kind of backwards there. I guess theories that have come up throughout the years is that the Vikings called them different things to kind of keep people away from Iceland because they would think that it's harsh. Okay? So Greenland is pretty harsh. So there's all these new studies that were being made, and he wanted to go study. From a young age, he wanted to go study Greenland. Okay? So obviously, from a young age, he decided to make himself be able to endure those harsh climates. Wegener became an educated man and received his doctorate degree in 1904. He specialized in the area of astronomy and the new science of meteorology, the study of weather. In 1906, his dream came true when a Danish expedition to Greenland invited him to join it as its chief meteorologist. While on the expedition, Wegener discovered a piece of data that bothered him for years to come. The data he collected about the island's longitudinal location did not match data that had been collected by others in the past. So, what is longitudinal location? So what is longitude?
Basically like where they were.
Tell your exact location.
Okay, so lines of the globe tell location, right? So, I'm sorry? Yes. So basically, he found that the longitudinal location that he gathered when he went was different from other data that somebody else had gotten years before. So what would that mean? If the location that the measurement that he got is different from years before, what does that infer? What inference can you make from that?
Either they were wrong or it moved. Or
Okay, either they were wrong or it moved. So that bothered him because really, land's gonna move? That's just crazy, right? In 1912, Wegener proposed the theory that at one time all the Earth's land masses were joined together, forming one giant supercontinent. He named the giant supercontinent Pangaea, which means all lands in Greek. Wegener's theory, called continental drift, was not well received by others. So, basically, in 1912, he decides to propose an idea that all the continents used to be stuck together, and he called that one supergiant continent, Pangaea. And the reason for it is because Pangaea means all lands in Greek, so all the lands together. Okay? Now, obviously, scientists aren't going to believe that, because once again, how in the world is this big landmass going to move? Okay? While fighting in World War I, Wegener was wounded in 1914. While recuperating, he wrote a book expressing his theory of continental drift. The following year, in 1915, the book titled Origin of Continents and Oceans was published. The book was not favorably received. So obviously scientists did not want to believe this theory of continental drift, that all these continents have moved. In 1928, the exclusive American Association of Petroleum Geologists invited Wegener to New York to present his theory. Wegener based his theory on 5 major pieces of evidence as described below. So he described 5 pieces of evidence, his evidence to support his theory. 1. The shapes of the continents of South America and Africa seem to fit together like the pieces of a jigsaw puzzle. This is especially true when you consider the actual edges of the continents which extend beneath the sea level, which are called the continental shelves. So, his first piece of evidence is that if you look at Africa and you look at South America, they sort of fit together like a puzzle, like they were stuck together before. Number 2, matching fossils of both plants and animals occur along the east coast of South America and the west coast of Africa. So what he realized is that if you went and looked at fossils of plants and animals on South America and fossils in Africa, so basically organisms that were here thousands and thousands and thousands and thousands of years ago, he found that those same fossils were in both places. What separates Africa and South America? An ocean, a pretty big one, right? So if you really think about it, is an organism or even a plant going to get from one place to the other?
No.
Unless they were closer together, right? So 3, matching folded mountain belts appear along the east coast of South America and west coast of Africa. So basically, the mountains seem like they match. What mountain belts basically mean is that if you really think, mountains aren't smooth, right? The edge of the continent isn't smooth, it's jagged, correct? Alright, so these jaggedness, these belts kind of match the ones in Africa. So this would be South America, this would be Africa. So that's what it means by the mountain belts kind of matching. Basically, they kind of fit together. Number 4. Evidence of ancient climates show that land masses were once located on different parts of the earth than where they're located today. For example, glacial deposits are found in hot tropical areas of Africa, and cold deposits, which come from lush tropical swamps, are found under the ice of Antarctica. So he found that the climates weren't the same before as they are now, because in Antarctica, he found cold deposits which come from tropical plants. Well, think about it. What climate does Antarctica have? Cold. Very cold. Is there anything living in Antarctica?
No.
No. But he found cold deposits from tropical plants. Where do tropical plants live?
No.
What type of climate?
Hot.
Hot. So how did these tropical plants get in this area that's really, really cold? Okay? Then in Africa, what type of climate does Africa have? Hot. They found glacial deposits. What's a glacier? Ice. Yeah. Do we find glaciers in Africa right now? No, you're not. It's really hot. So, but they found these glacial deposits, which are basically left behind by glaciers, in Africa, which means that at one time or another, Africa had glaciers. Okay? So that was his 4th piece of evidence. So his 5th piece of evidence is the data that Wegener collected about the longitudinal location of Greenland did not match the data collected by earlier expeditions. Therefore, Wegener believed Greenland was moving away from the continent of Europe. So, the longitudinal location of Greenland gave him an idea that Greenland was moving away. So, looking back at our 5 points of evidence. So, what was our first one, Menard? Okay. So, which two continents fit together like puzzle specifically? It's Miguel? Africa and specifically South America. So, South America and Africa, that's important. Make sure it's in your notes. Okay? Alright. Second piece of evidence, Eric. Or another one, it doesn't have to be in order.
Fossils found
Okay, fossils found where?
in Africa, east coast of South America.
And South America. So fossils, similar fossils found for both plants and animals. Okay? The third one.
We found tropical plants in Antarctica.
Tropical plants, well, fossils. Not actual tropical plants, but yes, fossils or deposits in Antarctica. And what did he find in Africa?
Glacier.
Glacial deposits. Okay? Alright, another one. There's 5 of them. I'm sorry? The mountain belts match from what two continents? Which ones have we been talking about? Africa and South America. And our last one?
The longitude of Greenland was changing.
The ground longitude of Greenland was changing. Okay? So those are the 5 pieces of evidence. That is what he collected to prove his continental drift. And remember, our essential question is, how does the evidence of Wegener help provide support for the continental drift? Okay? After Wegener presented his theory and supporting evidence to the American Association of Petroleum Geologists, he faced strong opposition and ridicule. He received comments such as he was eccentric, preposterous, and lacked common sense. One member even ridiculed Wegener by asking, what can you expect? He's only a meteorologist. So, even though he has all this proof, people still don't believe him. Because once again, how is it that these continents are moving when they're big land masses? How is it? That's hard for people to understand. Especially at a time that they didn't know what else was going on underneath.
Change is hard to understand.
Okay? Bless you. After the debate in New York, most of the scientific community dropped Wegener's theory. However, Wegener became more determined than ever to find answers to his questions. Why did the shapes of South America and Africa fit so well together? How did coal form in the South Pole? How did glaciers exist in tropical climate in Africa? Wegener continued leading expeditions across the earth looking for further evidence to support his theory. In 1930, Wegener returned to Greenland for his 4th visit. Ironically, the meteorologist became stranded in a blizzard and died. In our next lesson, you will learn that Wegener was very close to finding his answer. Actually, he was off by one island. The island of Iceland actually held the answers to some of his questions. Today, Wegener's research is accepted in a different light. Even though he did not have all the answers necessary to fully understand the movement of the continents, he did lay the foundation for today's understanding of our planet's geophysics. He is now referred to as a scientific hero who was ahead of his time and the father of continental drift. So, even though at that time his theory wasn't accepted, now we know his theory is correct. Okay? From evidence that we gathered after looking at another theory, which is the theory of plate tectonics, which is what we're going to look at tomorrow. Okay? So, to summarize, make sure that you have all 5 pieces of evidence for continental drift. But on a side note, do you realize how much this guy, this scientist, prepared for his dream? And he never gave up, even though all these people were telling him he's wrong, he's wrong, he's wrong. That's how science is. Sometimes if you become a scientist, you might come up with a theory or an experiment or prove something And you're going to get that pushback from scientists just because they want proof. Especially if you're coming up with something like that all the continents move. It's kind of hard to understand. So, are there any questions over the notes? All right, now, we're going to do an activity in which you're going to go through and actually look at what the Earth looked like in previous